Welcome back. This time, we'll have another problem for rational inequalities. A dressmaker ordered several meters of red cloth from a vendor, but the vendor only had 4 meters of red cloth in stock. The vendor bought the remaining lengths of red cloth from a wholesaler for 1,120. He then sold those lengths of red cloth to the dressmaker, along with the original 4 meters of cloth, for a total of 1,600 pesos. If the vendor's price per meter is at least 10 pesos more than the wholesaler's price per meter, how many additional meters of red cloth did the vendor purchase from the wholesaler? Now, we know that only 4 meters of red cloth was left by the vendor. So the vendor bought more meters of red cloth from a wholesaler. So let that be X, because we didn't know how many meters of red cloth the vendor purchased from the wholesaler. Now remember that the wholesaler's price per meter is 1,120 over X, because this is the total amount that was being paid by the vendor from the wholesaler divided by the number of meters of red cloth. And since the vendor's price per meter is 1,600, that's the total sale price, 1,600 divided by the number of meters from the wholesaler plus the 4 meters that were originally left from the vendor. Now the vendor's price, remember, is greater than at least, so it means greater than or equal to the wholesaler's price plus 10. So we substitute. The vendor's price per meter is this one. We copy. It's greater than or equal to the vendor's price per meter, this one, plus 10. Now, let's start with the smooth method. Remember that the left-hand side must have a single rational expression, and the right-hand side should have 0. You need to pause this video as you need to analyze how we have derived this original inequality to this single expression. Again, pause this video for a while. Hope you have learned how to derive the original inequality into a single rational expression. This time, using our derived inequality or a single rational expression, we need to solve for the numerator. For the meaningful values, for the numerator, we have x equals 16. For the denominator, we have still the numerator, x equals 28. And when we substitute this to our inequality, it will give us a true value. So 16 and 28 becomes the shaded portion of a circle. For the denominator, we also have 2, x equals 0, and the other one is x plus 4 is equal to 0, which is equal to x equals negative 4. So we have two meaningful numbers for the denominator, 0 and negative 4. But once you will substitute this one to the original inequality, it will give you a false remark. So for 0 and negative 4, the circles are unshaded. But for 16 and 28, the circles are shaded. We plot a number before negative 4, that could be negative 5. Between negative 4 and 0, that could be negative 2. Between 0 and 16, that can be 2. Between 16 and 28, that can be 20. And after 28, that could be 30. Then substitute it to the original inequality. Pause for a moment and check if you'll get the same remarks as I do. We found out that only the between negative 4 and 0 and between 16 and 28 have true remarks. So we darken the circle, the line, from -4 to 0 and from 16 to 28. But since we are dealing with the length of cloth, we discard the negative measurements. Remember, X stands for the number of meters that the vendor purchased from the wholesaler. So we'll only have 16 and 28. Expressing it in an interval notation, we have 16 in brackets since it's shaded to 28, which is also shaded. So the length of red cloth the vendor purchased and the wholesaler is between 16 to 28 meters. This ends problem number 2.